Okay, everybody, we are now tackling example 20, which again, if you're like, Miss Long, these proofs are way easy. I could do it in my sleep. Well, if that is the case for you, then I want you to try this one on your own. Please don't listen to my high-pitched, obnoxious voice as I do the proof. You should try this one on your own and then see if you got it right, which remember, even if your proof doesn't look exactly like mine, it doesn't mean yours is wrong. So just be careful if you're a little bit uneasy about what you got, just raise your hand and I can check to see if what you did is right. Okay, again, set up your little T-chart with your statements and your reasons. So I got my statements, I got my reasons. Okay, you guys, well, let's get going. So I'm given that D and B are congruent, which I already marked my picture. And then I already marked my picture that a segment AD is parallel to segment CB. Okay, so I know that, let's see here, angle D is congruent to angle B. I also know that A to the D is parallel to B to the C. And like we already know, that's because it was given to us. Yay. Okay, so let's get going, you guys. So again, if you guys can use anything from the given or previous statement, that will be helpful to continue your proof on. Okay? So do you guys see anything that might help us to have another step in our proof from the given? Do you guys see anything? I see it too, guys. This parallel line thing is like shouting in my face. It's like, use me. AD is parallel to BC. Use this in your proof. Okay, so since we know these are parallel lines, if you guys see here, we have two parallel lines that are cut by this transversal right here. Okay, so you need to think about those parallel line angle properties that we talked about when a transversal cuts through two parallel lines. So do you guys see any letters kind of appearing on your paper that might help us to mark, sorry, the Dean Cat's got me. That might help us to mark that angles are congruent or maybe supplementary. I don't know. Oh man, I see it too, guys. Do you see the Z? Do you see it? Whoa, there's a Z. Which type of angles make the Z shape? That is correct. Alternate interior angles make the Z shape. So before I get started, you guys, I need to declare that I have found some alternate interior angles. So I'm going to say angle DAC and angle ACB are, which I wrote way too big, sorry guys, are alternate interior angles. Sorry guys, I know it's weird that the statements is going into the reasons, I'm sorry. Okay, and how I know that is because alternate interior angles are on the inside of your parallel lines on alternating sides of the transversal, or they make the Z shape. That's the shortcut. So since that is what it means to be an alternate interior angles, what I have just done is I have defined alternate interior angles. So this is my definition of alternate interior angles. Okay. Now that we know that lines are parallel, what properties arise when we have alternate interior angles? That is correct. Alternate interior angles are congruent. So I can mark that on my picture. It's always good to mark your picture to see which triangle congruency postulates are appearing. Okay, so I'm going to mark those as congruent. So I'm going to say angle DAC is congruent to angle ACB. And how I know that? Well, I'm applying the alternate interior angle definition, which means I'm using a theorem. So this would be the alternate interior angle theorem. Alternate interior angle theorem says that alternate interior angles are congruent. Oh no, I messed up my color scheme. I'm so sad. Oh well, I'll get over it. It'll be okay. Okay, so I know that these two angles are congruent, but I need to show that at least three parts are congruent to use one of my triangle congruency shortcuts. So we're not there yet. Okay, so at this point, I'm out of things that I can use from my previous statements and reasons. Okay, I don't have anything else I can use. So this is when I use one of those tricks up my sleeves. there are several things you can do. And actually, now that I think about it, let me think just for a second. Okay, so there are two routes you could go. I'm going to show you the most efficient route. Okay. So I'm going to show you the most efficient route first. So one of the tricks up our sleeves is to show a shared or reflexive side, which, guess what, you guys? AC is located in both of our triangles. So I can say that AC is congruent to AC by the reflexive property. Okay, and I did not see this before, so I'm going to extend this down. Okay, so at this point, you guys, I do have enough information to show that triangles are congruent. But I'm going to leave this line blank for now because I can also include something else into my proof, which would allow me to show the triangles are congruent in two different ways, which is pretty cool. Okay, so you don't have to do this. You could just end your proof where I'm about to end my proof. It's really up to you. It's a personal decision. But I'm going to show you all possibilities, okay? So as of this point, let's see. How are my triangles marked congruent? Well, let's see here. I have an angle. Then the next thing I see congruent is an angle. Then a side. So this is angle, angle, side. Nice. Okay? And again, I see an angle. The next thing I see congruent is an angle. Then I see a side. So angle, angle, side. So as of right now, I can say, and again, they gave me the triangle congruency statement, so I don't have to come up with one. So triangle ADC is congruent to triangle CBA, and I know that because I'm going to write it in pink so you know this one was proved by this statement. Because of angle, angle, side. So this statement right here, well, and also these previous statements, but this one led me to conclude this. Okay, but you guys, there's one more trick up my sleeve that we can use in this proof. I don't have vertical angles, so no vertical angles, but since I know two angles are congruent in my triangle, that means that the third angles would also have to be congruent by the third angle theorem. So I could also mark in these angles as congruent by my third angle theorem. So I could say angle DCA is congruent to angle, let's see, BAC by the third angle theorem. Third angle theorem. Okay, which with the third angle theorem, guess what, you guys? There's yet another way I can show these triangles are congruent. Okay, if you guys see here, I also have an angle, then a side, then an angle. Angle, side, angle. So I can also show that these are congruent by angle. Sorry. Oh man, I wrote the wrong thing. Gee willikers, Miss Long. Can you please get your life together? I'm so sorry. One day I'll get my life together, you guys. One day. Okay, so another way to show these two triangles are congruent is by ASA. So using the third angle theorem, using this theorem, I can also say that they're congruent by angle, side angle. Okay, so there are two possibilities for this, which is pretty cool. Again, you could have just had the reflexive property and then had this last statement. Okay, but you know, we love to show how triangles are congruent in as many ways as possible. So I cannot mark anything else in my triangle congruent. So at this point, I'm done, which is pretty exciting, which means I need to include my happy face, which I did not forget this time. Okay, you guys, well, that's the last proof for now, but don't you worry, we have a few more proofs we'll be doing later on, so just hold your horses. We'll get to the proofs later on, so don't you worry. All right, well, nice job, you guys. That was great.